The first stars in the universe formed even earlier than astronomers had thought, a new study suggests. Researchers probing the early universe found no sign of first-generation stars in galaxies that existed just 500 million to 1 billion years after the Big Bang. These results have profound astrophysical consequences as they show that galaxies must have formed much earlier than we thought, study lead author Rachana Bhattacharya, a research fellow at the European Space Agency, ESA, said in a statement. Bhattacharya and her colleagues used the NASA ESA Hubble Space Telescope, NASA's Spitze Space Telescope, and the European Southern Observatory's Very Large Telescope in Chile to hunt for population III stars in a variety of distant galaxies. Population III stars were the first suns to form in our 8 billion-year-old universe, and they're identifiable by their unique composition. Just hydrogen, helium, and lithium, the only elements around immediately after the Big Bang. Heavier elements were forged in the cores of these stars and their successors. The somewhat confusing moniker results from the fact that astronomers had already classified the stars of our own Milky Way galaxy into two groups before considering their super-old cousins. Population I stars, such as Earth's Sun, are rich in heavy elements, and population II stars are considerably less so. The research team took advantage of a phenomenon called gravitational lensing to bring their hard targets into view. In each case, they used a giant galaxy cluster in the foreground as a sort of magnifying glass, allowing them to study small, distant, and incredibly faint galaxies. It has taken the light from these background galaxies 12.8 billion to 13.3 billion years to reach Earth, meaning that these objects are time capsules harboring lots of information about the early universe, including what types of stars were shining back then. We found no evidence of these first-generation population III stars in this cosmic time interval. Population III stars and the first galaxies must therefore be older still, so old that they're beyond Hubble's reach. But NASA's $9.8 billion James Webb Space Telescope, which is scheduled to launch next year, may be able to spot them, study team members said. The galaxies found in the Webb images appeared shockingly big, and the stars in them too old. The new findings are in conflict with existing ideas of how the universe looked and evolved in its early years, and don't match earlier observations made by Webb's less powerful predecessor, the Hubble Space Telescope. We had specific expectations for the type of galaxies that live in the early universe. They are young and small. Joel Leisure, assistant professor of astronomy and astrophysics at Penn State and one of the authors of the study, told Space.com in an email. Previous studies of the early universe with Hubble and other instruments tend to find small, blue, baby galaxies at early times, objects which have just recently formed out of the primordial cosmic soup and are themselves building their early stars and structures. Young stars in general shine bright blue. With age, stars develop a redder glow as they burn through their fuel and cool down. In ancient galaxies that Webb was built to spot, astronomers had not expected to see old red stars. They also had not expected to find galaxies more massive than perhaps 1 billion suns. But those reddish dots revealed in Webb's deep fields appear 50 times more massive than that, Leia said. The most massive galaxies in our sample are estimated to have masses 2 to 4 times lower than that of our own Milky Way, Leia wrote. This was astounding. we're finding galaxy candidates as massive as our own galaxy when the universe was 3% of its current age. Nobody expected them. They were not supposed to be there. And now, nobody can explain how they had formed. Galaxies nearly as massive as the Milky Way and full of mature red stars seem to be dispersed in deep field images obtained by the James Webb Space Telescope, Webb or JWST, during its early observation campaign. And they are giving astronomers a headache. These galaxies, described in a new study based on Webb's first data release, are so far away that they appear only as tiny reddish dots to the powerful telescope. By analyzing the light emitted by these galaxies, astronomers established that they were viewing them in our universe's infancy only 500 to 700 million years after the Big Bang. Such early galaxies are not in themselves surprising. Astronomers expected that first star clusters sprung up shortly after the universe moved out of the so-called dark ages, the first 400 million years of its existence, when only a thick fog of hydrogen atoms permeated space. The images that revealed these puzzling galaxies were obtained by Webb's near-infrared camera, NIRCam, as part of the Cosmic Evolution Early Release Science (SEERS) program. Astronomers plan to soon turn Webb's mirror to these galaxies again, to this time obtain light spectra of those distant dots. Spectra break down the observed light according to its wavelength composition and thus reveal the chemical and physical properties of its source. The most important thing is that spectra give very precise distances to these objects, said Leia. The distance and the identity of these objects is correlated. If we know the distance, we can pin down the identity and vice versa. So a spectrum will pretty immediately tell us if our hypotheses are correct. Only a little more than 6 months after the Webb team released the first observations from the Grand Observatory, scientists are already challenged to rewrite their theories about the early universe. Furthermore, scientists mentioned that we looked into the very early universe for the first time and had no idea what we were going to find, Leisha said in a Penn University statement. It turns out we found something so unexpected, it actually creates problems for science. It calls the whole picture of early galaxy formation into question. The new results, which were presented this week at the 236th meeting of the American Astronomical Society and will be published in an upcoming issue of the journal Monthly Notices of the Royal Astronomical Society, shed other light on the early universe as well. For example, low-mass, faint galaxies like the ones observed in the new study were probably responsible for cosmic reionization, Patadakar and her colleagues said. In this process, which began perhaps 400 million years after the Big Bang, radiation split the hydrogen atoms pervading the universe into their constituent protons and electrons. Reionization was a big cosmic transition, and getting a better handle on how it happened could help astronomers better understand our universe's structure and evolution, scientists have said. So friends, what do you think about this explanation? Write your views in the comments section, and don't forget to subscribe to our channel.